Friends, how are you? So, as we are continuing our thermodynamics series, in previous lecture we have already covered almost 102 questions of thermodynamics subject, which will be helpful for the various competitive exams like SSC JE, engineering sales exam, then GATE exam, and for other state exams. So, we are continuing with our thermodynamics series, and today we'll start with the question number 103. So first question for today, that is the the law of thermodynamics was developed by. So basically a Joule options are here, that is A Joule, B Kelvin, C Charles, D Carnot. So basically Joule's experiment was performed, which will give us a first law of thermodynamics. So according to Joule's experiment, so he performed a paddle wheel arrangement, paddle wheel experiment. It is paddle wheel experiment. And he proved that heat and work can be interchanged, means we can convert heat into a work and work into heat. And outcome of the Joule's experiment is that, or first law of thermodynamics is that the cyclic integral of del Q is equal to del W. That is, if any process or any system executes a cycle, then cyclic integral of del Q will be equals to del W, means during the process whatever the heat transfer will be equals to the work transfer according to first law of thermodynamics. That was proved by the Joule's experiment. So, and according to Joule's experiment, Joule's law also came into picture, that is internal energy is a function of temperature. So that is also important according to first law of thermodynamics. So here the first law of thermodynamics was developed by, the answer will be Joule. The next question, Joule's law state the specific internal energy of a gas depends only on. So according to Joule's law, here on screen you can see a Joule's law, that is question number 104. So according to Joule's law, internal energy is a function of temperature only. So here in option C will be the right answer, the temperature of the gas. So option C will be the right answer. The next question, the internal energy of an isolated system. Options are increases with addition of heat, increases with increase in mass of a system, remains same, increases with the addition of work. So here isolated system is the system where there will be no mass exchange as well as energy exchange with the surrounding. That means its internal energy will remain constant. So any change in internal energy will be zero. So here internal energy change will be zero. That means the internal energy of isolated system remains constant. That is the reason why any change will be zero. So here option C will be the right answer. That is the internal energy of an isolated system will be zero. That is it remains same, but the change in internal energy will be zero for an isolated system. The reason behind that is there will be no mass as well as no energy exchange with the surrounding in an isolated system. Some of the examples of isolated systems are, our universe is a isolated system. Then next example, that is a perfectly insulated thermoplastic and also an example of isolated system. Then next question, that is 106. Add the identity del Q is equal to du plus pdu is valid for. So here that is del Q is the heat transfer, then du is the internal energy change, and pdu delta V is the work done. So it is valid for options are any process occurring in an open system. Then next is the any process occurring in a closed system. Then next option, that is a quasi-static process without dissipation in a closed cycle, and last is the any process in any system. So here I think the correct options are option C, that is for a closed system if the quasi-static process is taking place, then del Q will be equals to du plus p dp. So this will be the option C will be the right answer for this question. The next question, the heat transfer to a closed stationary system, constant volume is equal to. So here volume is constant and heat transfer to a closed stationary system, the constant volume. Okay, so here for a constant volume system, according to the first law of thermodynamics, that is del Q minus del W is equal to du. So here this For close constant volume process, the del W will be 0. Okay, so as it is a constant volume process, so this del W is nothing but P dV. Volume will be constant, so dV will be 0. So here dQ will be equals to du. That means any heat transfer to the system, that will raise the internal energy. So in option B, the increase in internal energy. So option B will be the right answer for question. A shortcoming of first law of thermodynamics is, so options are direction of process, possibility of process, quality of energy, and quantity of energy. So shortcoming of the process is that we can convert one form of energy into another form. That is, according to first law of thermodynamics, we can convert one form of energy into another form. That is the first law of thermodynamics. The statement is nothing but the energy can neither be created nor be destroyed. It is converted from one form to the another form. That is the law of conservation of energy, and based on that, first law is the, that is nothing but the, by the symbol, that is del cyclic integral of del Q will be equals to del W. So this is the first law of thermodynamics statement or equation. So according to that, we can convert one form of energy into another form. So here it tells about the quantity of energy. It doesn't tells about the quality of energy. It just states about the that energy can converted from one form to the another form. Now how much it can be converted from one form to another form, how much will be the degradation will be there, so that is explained by the second law. So here first law, shortcoming of first law of thermodynamics is nothing but the, it tells about the quantity of energy. That is option D will be the right answer. In a steady flow process across the control volume, mass and energy flow. So in a steady flow process, the mass and energy flow is remains constant. So steady flow process, that means if you, there is a flow of say any fluid to the system, and it takes and it also rejects from the system. So here mass and energy flow remains constant. That is told by the steady flow energy equation. So here in a steady flow process, the mass and energy flow will be remains constant. So option B will be the right answer. During a throttling process, the options are internal energy does not change, pressure does not change, volume does not change, enthalpy does not change. So throttling process, which is also called as isothermal process. So in a throttling process, the enthalpy does not change. That means enthalpy remains constant. And during throttling process, we just allow flow of a fluid through a restricted area. Here we can see a flow through a restricted area. Here suppose there is a fluid that is flowing and having enthalpy H1, and if it's supposed to be flow through a restricted area, then its enthalpy will reduce. Its enthalpy remains constant, but pressure reduced to P2. Suppose this is a P1, then this pressure will be higher as compared to the P2 pressure. So here pressure will be reduced during throttling process, but here enthalpy remains constant. This will be the isothermal process. Then next question, during isothermal expansion process of a gas, so according to the first law of thermodynamics, that is del Q is equal to del W plus du. So even isothermal expansion, so here as you all know that the internal energy function of temperature, so whatever the change in internal energy during isothermal process will be 0. So here del Q will be equals to del W. So here the options are, during isothermal expansion process of a gas, pressure remains constant, temperature remains constant, then both pressure and temperature remains constant, none of the above. So here temperature remains constant during isothermal process, which is also called as a hyperbolic process. It is also called as a hyperbolic process. And one thing to be remembered is that during isothermal process, if the process is carried out at constant temperature, change in internal energy will be 0. That means del Q will be equals to del W for an reversible or isothermal process. So here option B will be the right answer. An ideal gas is filled in a balloon kept and evacuated and insulated room. When the balloon ruptures, the gas fills up the entire room. Now internal energy of a gas and the enthalpy of gas at the end of this process will be. So here that the balloon is kept in a evacuated and insulated room where balloon ruptures, so it will fill the all the gas in the balloon will be leak and it will fill up the entire room. Now internal energy, as you all know that the internal energy function of a temperature. So here though it gets rupture, so its internal energy and the enthalpy remains constant because they are both a function of temperature. As the temperature of room remains constant, so it will remain constant. So here the option C will be the right answer. The next question, that is question number 113. The change in enthalpy of a closed system is equal to the heat transfer if reversible process takes place at constant. So here during constant pressure process, del Q will be equals to change in enthalpy. So here del Q will be equals to del H. Similarly, that is during a constant pressure process, del Q will be equals to, that is whatever the heat transfer will be equals to change in enthalpy of a system if the process is carried out at a constant pressure. Similarly, if the process is carried out at constant volume, that is volume will be constant, then that in that case whatever the heat transfer to the system will be equals to the change in internal energy of the system. So for current question, the answer will be is option B. Next question, the gas expands for a definite volume in a closed vessel. The maximum work will be done when process is at constant. So here I will draw different processes on PV diagram so that we can understand. Suppose if you draw a process that is a constant volume process. So in constant volume process, a line will be vertical, and we all know that the during the constant volume process, that is whatever the area under the curve on PV diagram gives us about the work done, that is work done by the system or the surrounding. So here area under the curve is 0 for a constant volume process, so it will be work done will be 0 during constant volume process. Now next I have draw a isothermal process on PV diagram, isothermal, then polytropic, or then adiabatic process. So its curve comes out to be like such, that is a process 1 to 2. So here work done will be equals to the area under the curve, so this will be the, this much will be the area. Now if I draw a constant pressure process on TS diagram, so area under the curve will be the this, that is this area. Suppose I am considering this as a 1 and plus this area. So here one can say that during a constant pressure process, the work done will be the maximum. Out of the all the processes, work done will be the maximum during a constant pressure process, because the area under the curve is more as compared to the other processes. So here option C will be the right answer. So for gas, that is the gas expands for a definite volume in a closed vessel, the maximum work will be done when process is at a constant pressure. Reason behind that is that during a constant pressure process, that is the whatever the area under the curve is more, so here the maximum work will be done. So option C will be the right answer. The next question, the during mixing of streams in a case of air conditioning, the process is associated with, that is I will draw it on a screen. Suppose I am considering there is a mixing of streams in an air conditioning, means there is a duct where suppose M1 mass of air is flowing in one duct 1, then M2 mass is flowing through duct 2, and there will be mixing, that is M1 plus M2, this will be equals to M3. So this mixing of air streams is nothing but the adiabatic mixing. It is called as adiabatic mixing of air stream. So option B will be the right answer for the given question. The heat absorbed or rejected during polytropic process is equal to, here are number of the options, so out of which the option D is the right answer. So work done for a polytropic process is nothing but P1 V1 minus P2 V2 upon N minus 1. So here heat absorbed or rejected during the process will be equals to, the option D will be the right answer, that is gamma minus N upon gamma minus 1 into work done. So here option D will be the right answer. So here option D is the correct one. Then last question, the next question, that is the what is the rise in temperature of 80 liters of water in 40 minutes by a heater of 2 kilowatt if whole of the heater energy is used to rise the water temperature. Yes, so heat transfer, that is here there will be sensible heat transfer. So Q will be equals to, it is mCp dt, but this Q can be written in terms of power, that is power is nothing but work per unit time or heat per unit time. So here it can be written as power into time is equal to mCp dt. So here temperature changes, it is the, you have to calculate, Cp is given, that is 4.187, or it is taken as here given is 4 point, so it is not given, so you can consider that as a 4.187. 4.187 kilojoule per kg, that is a specific heat of water. Then next is the mass is also given, that is 80 liters, that will be equals to 80 kg because its density is 1000. So here it can be written as a 80 kg, and that is in 80 minutes. So here just we have to use the formula, that is P into the power is equal to 2 kilowatt, 2 into time is 40, that is in noted as 60. This will be equals to 80 into Cp is 4.187 into delta T, that we have to find out, and final answer comes out to be 14.3 degrees Celsius. So here option A will be the right answer for given question number 118. In a reversible isothermal expansion process, a fluid expands from 10 bar and 2 meter cube to 2 bar and 10 meter cube. During this expansion process, 100 kilowatt of heat is supplied. Then the work done during the process is. So here for isothermal process, as you all know, that internal energy change is 0. So here one can say that del Q will be equals to del W. So we don't have to solve all those things. So here del Q, what is the value of, whatever the value of del Q will be equals to the del W. Here del Q is 1000, or sorry it is 100 kilowatts. So here del W is also 100 kilowatts. So option C will be the right answer. The next question, in an adiabatic process, 5000 joule of work is performed on a system. So here, and the system returns to its original state while 100 joule of heat is added. So in first process, that is adiabatic process, here 5000 joule of work is performed on a system. It is not by the system, that is on the system by the surrounding. That means it will be negative, that is 5000 joule. And if you apply the first law of thermodynamics, so it should be what del Q minus this will be equals to du for process 1 to 2. So here del Q will be 0 as process is adiabatic between 1 to 2. So here du will be equals to, that is minus become plus, that is 5000 joule. Here internal energy change during process 1 to 2 will be 5000 joule. Then next, that is the, and it returns to the original state, that means 1 to 2. If suppose it goes from 1 to 2, and here the internal energy change is 5000 and work done onto the system is also 5000, but here it transfer is 0. So here again it goes back to from 2 to 1, and here work done that we have to find out. So here to find out work done, so here it transfer is 1000 joule, and it is heat added to the system, that is positive. Whatever the heat added to the system is always positive, minus del W for process 2 to 1. This will be equals to du, that is from process 2 to 1. Now here del W that we have to find out. Now here this is 1000 minus del W is equal to, it can be written, du can be written from 2 to 1, that is it can be written as minus 5000, that is here it can be written as u2 minus 1. So instead of this you can written as it as a minus of u1 minus u2. So here u1 sorry minus of u2 minus u1. So here it can be written as minus 5000. So here del W can be written as, that is minus 5000 minus 1000. This is comes out to be minus 6000. So here del W, minus of del W will be equals to minus 6000 joule. Here del W will becomes out to be 6000 joule, and it is positive, that means it is a work done by the system onto the surrounding. So here option C will be the right answer for given question. So here next question, that is in a heat exchanger 50 kg of water is heated per minute from 50 degrees Celsius to 110 degrees Celsius by hot gases which enter the heat exchanger at 250 degrees Celsius. The value of Cp for water is 4.186 kilojoule per kg Kelvin, and for air is 1 kilojoule per kg Kelvin. If the flow rate of gases is 100 kg per minute, the net change in enthalpy of air will nearly be. So here just we have to use a equation, that is heat transfer from the air or gases will be equals to the heat gain by the hot water. So here use a simple formula, that is whatever the sensible heat gain will be equals to the loss of heat from the hot gases, that is mass of air into the enthalpy of air. Here I assume that the air is the used as a gas for the heating purpose. Here all the things are given, that is mass flow rate of water is 50 kg, then specific is 4.186, then it is rated for near about, say, in order to rise the temperature from 50 to 110, that is for 60 degrees Celsius. Then so here mass of air is 1, it is taken as mass, the flow rate of gases is 100 kg per minute. So here put those in equation that is given below here, that is whatever the heat lost by the gases will be gained by the water. So from that we will get the final answer, that is 12.6 megajoule per minute. So remember this, all those things are given in kilojoule, so we have to convert into megajoule because units are given in megajoule. So there will 1 megajoule is nothing but 10 raised to 3 kilojoule. So remember those things, and if you put all those in equation, we will get the final answer, that is 12.6 megajoule per minute. The next question, a system executes a cycle, okay, during which there are 4 heat transfers, that is Q1 to 2, Q2 to 3, Q3 to 4, Q4 to 1. The work done during the processes is W1 to 2, W2 to 3, W3 to 4, and here W4 to 1, that we have to find out. Okay, so use simple formula, but before that remember one thing, that is work done by the system onto the surrounding is taken as positive, and work done by the surrounding onto the system taken as negative, and vice versa. Heat transfer from the system to the surrounding taken as negative, and heat transfer from surrounding to the system taken as positive. So here this must known to us, and according to cyclic that is the first law of thermodynamics, cyclic integral of del Q will be equals to cyclic integral of del W, and integration, that is tell us about the addition. So add those things, all those things. So here 220, then next minus 25, then minus 180 plus 50 will be equals to whatever the work transfer, 15 plus minus 10, then plus 60 plus W 4 to 1. After putting all those in equation, you will get the final answer, that is W 4 to 1 is, this comes out to be 0 kilojoule. So option B will be the right answer.